Hi everyone, I'm Jasper. Welcome to this code lab, Developing Progressive Web Apps, Responsive Design Part 1. We'll be looking at Viewport tag in this part. This is for ALC4 MWS Team 60. And it's by no means endorsed by Andela or Google, but it's just for teaching each other in this group as we move towards the journey of becoming certified mobile web specialists by Google. The prerequisites of this lab are: 1, you should be comfortable with HTML, and 2, you should be comfortable with CSS. Otherwise, everything that you need to know about the Viewport tag, you get from this lab. Thank you. Right, before we jump in, there's a bit of setup which need to be done. Download the starter files from this GitHub URL. Then you also need to have Node.js installed. Also HTTP server, but you can use your preferred local web server. In your terminal, navigate to Responsive Design Lab/app and start the server. Here I used port 8080. Open your browser at localhost 8080. In your favorite IDE, open the Responsive Design Lab/app folder, and you see these files, index.html, and the styles folder, which contains main.css. You also see the modernizer.js. You may need to unregister any service workers and clear all service worker caches for local hosts so that they don't interfere with the lab. Now opening our index.html page, I'll be using Atom IDE. You'll see here that we have the main div with a class of container, and it contains 3 children, which are all divs, with a class of COL. I think it means columns. It's a small, simple page, but it suffices to teach us what we want to know. So we'll be developing this until our page is responsive. Now, going to our style sheet, that's main.css. We see that there's nothing much in here. Just selecting the container and setting the background color and the overflow to auto. And here the width is 27% for all the columns, just to make them fit in one row. Then we'll be using this again, our main CSS, to style our index.html. Right, we've seen how the style sheet and the HTML looks like. Now moving on to localhost 8080 to see the browser, to see how the thing looks on the browser. You see that our page is not responsive at all. It's just zooming in and zooming out, as you can see here. Actually, the default behavior of the mobile pages, mobile browsers, is that they render the page at desktop width of around 980. So this is around 980, and then they try to make the thing look nice by zooming down. As I zoom down, you see, it's not, the content is not reflowing, but it's just being squashed and squashed up to a point that you can't even see what's written in there. So that's the default behavior of the mobile pages, how they render the pages. If I zoom out from 980, you see now that the content is reflowing. It has now detected that this is a desktop. But for the mobile browser, they zoom at 980 or thereabout, and then squash it, zoom it down. You see. So our page is not responsive at all. It's difficult to see because here we are designing for mobile, and say let's put something here, maybe an iPhone X. You see, you can't see anything here. Can't see anything, but we will sort it out. Now we've seen in the browser that our page was not responsive at all, especially that the content was not reflowing, but was just being zoomed in and out. Now enter the meta viewport tag. This tag, it controls the width and scaling of the browser's viewport. Now maybe I may explain a bit what this browser's viewport is. You remember I mentioned before that the default behavior of mobile browsers is that they render the page at desktop width for around 980, and then try to make the things nice by zooming it down to fit into the device's width. Now the browser's viewport, it is that 980 pixels, or it is that where the page, the mobile browsers render the page. Width equals device width. It matches the screen's width in device independent pixels. At the end of toward the end of this presentation, I will speak more about this device independent pixels. But for now, just know that it matches the actual width of our device. And this allows the page to reflow content to match different screen sizes. You see, when you looked at the demo, at the initial page, you see that content was not reflowing, but was just being zoomed in and out. So this now, this tag, it allows this reflow of content by using the width equals device width. The font will be what we expect it to be. It will not be zoomed in or out, but it will be just the right size that we designed it to be. The initial scale equals 1. It establishes a one-to-one relationship between CSS pixels and device independent pixels. Again, towards the end, I will speak more about what these CSS pixels and device independent pixels are. But this initial scale equals 1, I may say it's a bit of a hack, in that some browsers, when you turn from portrait to landscape, instead of reflowing the content to fit the extra space available, they instead keep the portrait width and then zoom it to fill the landscape space, which is not what we want. We want it to manage it properly by reflowing and filling this space. So this initial scale goes to 1, takes care of that. Now moving back to index HTML, we want to add the viewport tag. We put it in the head. It should be between the head tags. Then just save here, and we go back to check our browser. Right, moving back to our localhost, to our browser, we see here that the font is now normal. That's what we expect. At least we can read what's written in there. And if I resize, you see that the content is now reflowing. It's not just being zoomed in or out, but it's reflowing. You see, if I say I go to landscape, you see, it's reflowing. That's what we expect. So the viewport tag has done its job. These are the problems of, things being crammed together. It's a challenge that we are going to solve using other methods, but otherwise the viewport has done its job. Right? There are some things which you must be aware of when it comes to the viewport tag. I think let me demonstrate by an example here. Let's set our outside container to a width of 100 rems, right? And let's go back to our browser and see what's happening. iPhone X still selected, but look what is happening. Mind you, our viewport tag is still in place. See, here it is. But here we are forcing the user to scroll horizontally, giving a very bad user experience. So we must be very careful when it comes to widths that you set to your content, or it may be the images. Those widths, they must not resolve to anything that is greater than our device width. Otherwise, we'll force the user to scroll horizontally. So use something like width is 100% rather than using pixels or rems or even EMs, because those, the rems and EMs, though they are not absolute values, but they can resolve to a length that is greater than our device width. So be very, very careful. Now, as promised, let us now look at some few definitions of these pixels. I'm sure you have heard from in the dev corridors that a pixel is not a pixel. And I can vouch that this statement is true. What is a CSS pixel? Right? I think this one deserves a moment of silence as I read this. He says, CSS pixel is a unit of length which roughly corresponds to the width or height of a single dot that can be comfortably seen by the human eye without strain, but is otherwise as small as possible. By definition, this is the physical size of a single pixel at a pixel density of 96 dpi, located at an arm's length away from the viewer's eyes. Whoa. Hold the horses. Before you shoot, don't shoot the messenger. Let me point you to your victim. From the horse's mouth, MDN web docs. That's the definition that you find in there. Okay, let's just put this one behind us and let me just explain what they wanted to say. What they are saying here, what they are trying to say is that they want 96 pixels, which we write in our CSS as px. They want 96 of them to fit in 1 inch as viewed from the device screen. That's what they wanted to say. So I think they were a bit maybe shy or whatever, but that was the definition that they wanted to say. Then move on to device or physical pixel. This one comes from me, yours truly. And as you know, we are developers. We are fond of reusing code. So I'm reusing that definition of MDN web docs, and to be brief as possible. And here we go. So the device pixel is that single dot referred to by MDN web docs. And this is from yours truly. I think this is clear, and I deserve a round of applause on this. Now moving on to device independent pixel, abbreviated as DP or DIP. It is a virtual pixel unit equivalent to one device pixel on a 160 dpi screen and scaled proportionally on higher or lower density screens. If you've not been into Android or a mobile development, maybe this may be new, but in those circles, this is not new. It's very common. Actually, there is a length which they call DP, which you can actually use. So I think this one deserves a bit of explanation. Yeah, because in our definition on that viewport, we saw that the width is equal to device width. It matches the device width in device independent pixels. So I think let me explain a bit further on this and why do we care wanting to know that, and what's the good thing of this DP or DIP. Right, let's look more into this device independent pixels thing. I have here this tablet and this smartphone. The tablet is at 160 dpi and the smartphone is at 320 dpi. Right, and you have here this rectangle or ribbon which is passing through both devices. Right, and this rectangle, I gave it an arbitrary let's say height of 100 dp, which is 100 device independent pixels. Right. According to the definition that we saw earlier, in this tablet, this corresponds to 100 pixels. But on this 320 dpi now, you see the height is 200 pixels. It's times 2, right? So you see, and take note that these are device pixels, not CSS pixels. There's a difference there, right? So I think from this you can appreciate the beauty of DP, because it's not ambiguous. This 100 dp is the same in the tablet, which is 860, and it's the same in this smartphone, which is a 320. The same value exists in both these scenarios. But look what's happening to the pixels, the device pixels. It's changing depending on the screen that you are looking at. So the DPs, they capture the physical dimensions of a device more accurately and in a sort of constant manner, which is not ambiguous. So I think maybe you are seeing the goodness here. Now, in that Viewport tag, you remember the width is equals to device width, right? So that device width is being captured in device pixels and is passed into the width. And that width, like I said earlier, is referring to the browser's viewport, not the device. So in a way, it is now changing. In case of the iPhones, like I said, they render at 980. So they are changing that 980 to be exactly equal to the device width in device independent pixels. And the initial scale is equals to 1. You remember we said it sets a 1-to-1 ratio between CSS pixels and device independent pixels. And I mentioned that this is done so that when you move from a portrait to landscape in browsers, and I think it should be on iPhones, they don't change the device width. It remains reporting the device width of the portrait. Whereas in other devices like Android, yeah, it changes to mesh now that you are now in landscape, and it takes that width, which is now being portrayed by the landscape, as the new width. But in iPhone, it doesn't do that. It just wants to zoom. So setting that 1-to-1 ratio now forces or mimics the changing of the device width on the browsers, which otherwise don't support that. So I think that's there's more to it, but I think for this purpose and for this lab, it suffices, and I believe that you are getting something. In part 2 of this code lab, we'll be looking at media queries to rearrange our columns at certain breakpoints. See you then, and thank you.